To get an even number, you either have to obtain 2, 4, or 6. Well, but that can be summarized simply as a subset. 1 for 2, the second for 4, and the third for 6. So we want to know what is the chance that we get an even number. So we want to calculate the probability that the event of getting an even number occurs. So to calculate that, well, at least in the discrete case, we have to just count the number of elements that we have in the event and make a fraction with the number of elements in the sampled space. So for this example, it's simple enough. We simply calculate this. But as a summary, this is 3/6, which is 1/2. Now, let's take a look at another one, just another example. Tossing a coin twice. Two times. Well, the experiment is tossing a coin twice. The sample space, the possible number of outcomes, all possible outcomes, constitutes something like this. Well, what are the things that we can get when we toss a coin twice? Well, it could be that you get tails with tails, tails, then heads, heads, then tails, or heads and heads. And we can set an event which can be described in words like this: obtaining at least one head. Well, as we have seen before, an event is a subset of the sampled space. In this case, obtaining one head, well, excluding this one, TH, HT, HH. So in this case, the probability, understood as a fraction, of obtaining at least one head is the following: is the cardinality of the event divided by the cardinality of the sample space. But well, this can be summarized as 3 divided by 4. So anytime that we want to calculate the discrete probability, we have to understand these 3 things. What is the experiment? What is the thing that we're doing to which we can observe an outcome? What is the sample space? What is the set of possible outcomes of this experiment? And what is the event that we're interested in calculating its probability? Meaning, what is the subset of the sample space that we want to study? We all have to answer these 3 things. And in a moment, I'll show you one little example.